Hey there, welcome back to Everything's a Project. Want to try to do a quick video. First part of it's going to be figuring out the bolt circle. This is a fuel tank. It was making a fuel tank adapter, so it has the in and out lines, the vent line, and electrical bungs for the fuel pump. So best way to do this stuff, this is sheet metal. So when it's thicker material, I like to put pins in it and measure the pins, but since it's sheet metal, that's not real practical. So what you do is take your calipers, and these are small holes, so it'll center pretty easy. Wiggle it a little bit, find the high spot of the holes, take that measurement. So in this case it's 3 inch 379. Plug that into your calculator, 3.379. So, and notice I put a parentheses first because we're going to average these out because this is just mass produced, so don't just do one location. Okay, so then subtract the hole size, one hole size. So that's 1 inch, or sorry, 0.169, 169 thousandths. And then your parentheses again, plus your second measurement. We'll go to this one, I guess. Go straight up. Give it a wiggle. Yes, this one's different. So this is 77. Oh, not too bad. 3.377 minus one of the bolt holes. $64.164. So now the two add up to 6.423. Divide that by 2. And that's our bolt pattern, 3.2115. So then, if you have a DRO on your mill that has where you can program a bolt circle, you divide that number in half, that's your radius, and then tell how many holes, and this, it's 8 holes, and they are symmetrical, so it makes a bolt pattern easy. If they're not symmetrical, that's where it gets tough. Then you got, best way is to find your center, so you might have to make a puck and then go to each location and make a coordinate system. Okay, so that was that part. Now we're going to switch over to the mill. Let's see, get the camera set up. How's that? Okay. So this plate is what we're going to make for that fuel tank. How do you find the center of this when it's thin? You know, because you got to use a V block to help, help hold it from spinning. Because like this gets a pipe thread, which is a little more tool pressure. You're going to be drilling, and it'll want to rock. So what you do? First thing you do is just drop it in the floor of your vise and tighten it up. Now, do your edge finder. Edge find it front and back of the inside of the jaws. And then divide that number by 2, that's your center. Okay, now it's time to cut it. So you only did your Y center so far. Now, you're going to use a V block to support to hold the material better. And then you're going to use parallels to raise the material up. Plus, this parallel is stood off from the point of the workpiece because of the V-block, and that'll keep it from wanting to flop. If you put the V-block on the movable jaw, your center stays the same. Probably technically stays the same the other way, but you always want your reference to be the fixed jaw. So now that you've figured out your center, and you have your workpiece in place, I'm just eyeing it up. I'm not doing all the actual firing it. And now you do your Y touch offs with the edge finder, and then divide that number by 2. And now that's center. Circular parts are best to do center. I had to make an adjustment on the fly, so there's a little bit drawn out here. But I'd also measured the opening in that tank, so it tells me what area I can work with. And that's what the grade area is. And then these are true size to help visualize it. But one thing I overlooked with the true size, those are the holes, and it didn't take into account the total OD of the component. So these I had to relocate. So this is the finished product. So I only have one sample of this. It's not bolted in because it's a bulkhead fitting. They gotta have the nut on there. But so you got 2 of these fittings, 2 of these. These are for the electrical. And then I think that's a vent. It's a race car, so it might have a rollover valve, and I did those. I've done those before. Those are tough because those are fuel thread. But bolt pattern works good. We're gonna swing around one more time. I'll show you my shitty tripod. Hey, we gotta get a tripod. Keep forgetting. Can you see the hole? Yep. So there we go. And that's how it'll be, something like that. The customer will determine the orientation and the clocking of the fittings, but everything lines up and you can change any position. Okay, and since I have this set up, it reminded me of another thing, and I've seen online some people doing what I consider the hard way. You want to find the center of a large diameter circular part. So say I want to put a keyway in this. You know, we're going to say this is a shaft. Okay, so how do I easily, okay, so I'm holding it there. How do I easily edge find this piece? So one of the things you can do, if you lock the quill, you can touch, then you got to crank all the way around and go to the other side. Because to do this round part, you have to be touching at the same height. So you're at the same point of the radius. Along those lines, you can lower the table. You mark your table and as a reference, lower it, all that work, cranking it, then clear it, go to the other side, and come back. Third way is you could use the stop on the quill and raise the quill and lower it. And then the other way that people are shown is the tool that pivots on here. You put it in your quill and then it squares up once you're on center. All that is too hokey in my book. What you do as you shift the part back. Tighten in your jaw. And edge find between the jaws. Boom, boom. Divide that number in half. That is the center line of the workpiece. Slide the workpiece back in the chuck. And you're ready to cut. Okay, so hopefully that's one of my better videos, faster videos. Hopefully I didn't say too much, but thanks a lot, and I wanted to share that with you. I couldn't share making this because the customer's coming to get it today, and I had to get it done. Okay, have a great weekend, and remember what Memorial Day is for.